last video that was doing questions 1 to 9 for the June 2018 Foundation Paper 1 from AQA. Okay, so question 10. Here's a list of numbers. Okay, we've got some numbers here. Work out the median. Now the median is the middle number. Okay, that's what the median means. It sounds a little bit like medium. So if you think of median sounding like medium, then it means the middle number. Okay, it's like the middle thing. So what we need to do first is we need to write the numbers out in order. Okay, and then the median is the middle number of those numbers when it's written out in order. So we've got 1, 2, 2, 3, 4, 5, 5, 5, 6, 8. Okay, now what we need to do is we need to find the number that's in this list that is the same number of steps away from the beginning as it is to the end. Okay, now the quick way to do this is to say, well, how many numbers are there? Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Okay, so what I'm going to do is I'm going to do 10 divided by 2 to find the middle, okay, which is 5. So I need to count 5 numbers in from this end. So I go 1, 2, 3, 4, 5, which gives me 4. And then do the same from this end. So 1, 2, 3, 4, 5, which gives me 5. Now the problem is when we have an even number of numbers and we're asked to find the median, there won't actually be a number that's in the middle. So what we have to do is we find the numbers like I've just shown you. So we divide the number of numbers by 2, so we cut them in half, and then we count and we find the number that's 5 from this end, and then 5 from this end, and then we find the number that's in between those two. So we take the mean of the two middle values, okay? So if we take the mean of 4 and 5, the mean is adding the numbers together and then dividing by however many numbers there are. So there's 2 numbers, divide by 2. So it gives us 4 and 5, which is 9, divided by 2, and then we get 4.5. Okay, so the median is 4.5. Now the next question is to work out the mean. Okay, so I'm just going to do this here so we can see the numbers. So the mean is where you add all the numbers together and then you divide by however many numbers there are. Okay, so let's add them all together. So we've got 5. Let's add all the let's add the 5s together first. 5 and 5 gives us 10. Let's do 8 and 2 gives us another 10. Let's do a 5, a 4, and a 1. That gives us another 10. Then let's do a 6 and a 3. That gives us a 9. And then a 2 gives us an 11. Okay, so we have 1, 2, 3, 41. Okay, and then we need to divide by however many numbers there are. Okay, so there's 10 numbers in total. So to get the mean, we do 41 divided by 10, which is simply 4.1. Okay, and that's the mean. There we go. So next question. So 300 passengers go on a coach trip. Each coach takes 50 passengers. Each passenger pays £25. The table shows the costs for the coach company. Okay, so the cost for each coach is £90 per driver, 70 pence a mile, okay, and each coach travels 200 miles. Okay, work out the total profit for the company. Work out the total profit the company makes from this trip. Okay, so the first thing we need to realise is what profit is. Now, profit is simply money in, take away money out. Okay, or you could say sales minus costs. Okay, so if you go to the coffee shop and you buy coffee for £5, you hand £5 over, but the coffee shop had to pay £3 to make that coffee. So they've made a profit of £2, okay? So this is what I mean. So you pay £5, that's their sales, and then it costs the coffee shop £3. So the profit would be sales, which is £5, take away costs, which is £3, which would be £2, okay? So that's what we need to work out. Sales minus costs. So let's work out the sales first. So sales is going to be the number of passengers times by the cost per passenger. Okay, so it's going to be 300 times by 25. Okay, that's the money in. Okay, now I'm going to use my calculator just because it's quicker. So that's going to be 7,500. Okay, now you could have done this in your head, so you could do 3 times 25, which is 75, and then 2 zeros, 7,500, okay, pounds. So that's the money in. So the costs, okay, costs. So it's important to realise that the costs are for each coach. Okay, so that implies that we need to figure out how many coaches there's going to be. Okay, now if each coach can take 50 passengers and there's 300 passengers, then the number of coaches, I'm going to call this n, is going to be equal to 300 divided by 50, which is going to be 6 coaches. Okay, so there's 6 coaches. I'm going to write the costs for 6 coaches in this. I'm going to make a new column. Sometimes these questions do give you a bit of extra space, so 6 coaches, and it's good to use this extra space to write these sorts of things. So the pay for each driver, so each coach needs 1 driver, is £90. The pay for 6 is going to be 90 times 6. Okay, so let's do 9 times 6 is 54. Because it's 90, it's 540. Okay, now 70 pence per mile. Okay, so let's do. So we need to know how many miles they're going to travel. So there's 6 coaches. Each coach travels 200 miles. So the total number of miles is equal to 6 times 200, which is equal to 1,200 miles. Okay, so now we need to do 70 pence per mile. So I would do 12 times 7, okay, which gives us, what's that, 84, okay, and then I need to realise, well, I need to put 2 zeros on the end, because I did 7 times 12, so that gives us 8,400, but this is 70 pence, not 7, so I divide it by 10, so it's going to be 840. Okay, just double check that's right, 0.7 times 1,200, yep, 840. So the pay for the driver is 540 for 6 coaches, and the payment for fuel is £840. So the total costs, let's add these together. So 840 add 540, so 8 add 5 gives us 113. 4 add 4 gives us 8, so it's going to be 1380. Okay, 1,380. So if the costs are 1,380 and the sales are 7,500, then the profit, I'm going to call it P, is going to be 7,500, take away 1,380. Okay, so that gives us 6,120. Okay. Right, next question. 16.4 minus 3.92 plus 7.8. Okay, so what we do here is I would do it like this. So I'd go 16.4, okay, put a 0 on the end. I'm going to do a column subtraction to do this. Okay, so 0 take 2, we can't do that, so we do 3 there, borrow the 1. 10 take 2 is 8. 3 take 9, we can't do that, so what we're going to do is we're going to borrow a 1 from here. So it becomes 13 take 9, which gives us 4. 5 take 3 is 2. 1 take 0 is just 1. And then don't forget the decimal point. 12.48. So we end up with 12.48 plus 7.8. And then we're going to do the column again, but this time it's addition. 7.8, put a 0 on the end. 8 add 0, 8, 8 add 4, will be 12, carry the 1. 2 add 7 is 9, add the 1, 10, carry the 1, 1 add 1 is 2, 20.28. Okay, so essentially we're just doing this bit first, and then we're doing this bit, okay, once we've worked out this. That was 12.48, which is what we got there, and we just add up the 7.8, okay, so make sure you can do your column addition and column subtraction when you're doing this. That'll help you out quite a lot. Okay, so next one, so 2,843 divided by 7, 0.61 divided by 7, sorry. Okay, so this is going to be difficult to do on its own. Okay, so what we're going to do is we're going to times this number by 100 to get rid of the decimal point, okay? So 2,843,6,1. Okay, so we've times by 100. Okay, it's important to realise that we times by 100, because if we times this number by 100 and we still divide it by 7, then 7 is gonna go into it 100 more times than whatever our answer to this is going to be. Okay, so 7. We use the bus stop method. 2, 8, 4, 3, 6, 1. It helps to space your numbers out when you're doing the bus stop method, just so you can write in the numbers that you carry over. Okay, so 7's into 2 is 0. Okay, 2 left over. 7's into 28 gives us 4. Okay, 7, 14, 21, 28. And then we have none left over. Okay, so that's 0. 7's into 4 is 0. 7's into 43. So 5 7s are 35. Okay, so that's going to be 5. But we're going to have, oh no, sorry, my mistake. We're going to have 35 and then add 7s, give us 42. Okay, so I made a mistake there, 42. So that's going to be 6, remainder 1. 7's into 16 is going to be 2, with 2 left over. And then 7's into 21 is going to be 3. Okay, so our answer to this sum here, not this one just yet, is going to be 40,623. Okay, now because we multiplied the number that we're dividing by 100, our answer is going to be 100 times bigger than what it should be. So that means that we have to divide by 100. Okay, so we times by 100, we have to then divide by 100 to make sure that we get the proper answer. Okay, so the proper answer is then 406.23. Okay, so if our decimal point's here, dividing by 100, we move it 2 spaces to the left, so it becomes there, yeah? Okay? Right, next one. Okay, in a game, 2 fair spinners are spun. Okay, now this one says if the numbers the arrows land on are different, the score is the higher number. If the numbers the arrows land on are the same, the score is 0. Okay, so what this means is it means that if we get 2 numbers that are the same, when we compare the rows and the columns here, it'll be a 0. If the numbers are different, we take the higher number. Okay, so let's have a look. So what have we done here? So with 1 and 2, the numbers are different because 1 and 2 aren't the same, so they've taken the higher number, which is 2. Okay, now let's say they do 2 and 1, it's going to be the same, 2. 3 and 1, so the numbers are different, so we're going to take the higher number, which is 3. Okay, then we just repeat this for all of them. 2 and 2, numbers are the same, it's going to be a 0. 2 and 2, that's filled in for us. 3 and 2, numbers are different, therefore higher number. 5 and 2, numbers are different, therefore higher number. 4 and 2, higher number. Higher number, higher number, higher number, so on and so forth. Okay. So then the question is saying, write down the probability that the score is an odd number. Okay. Now, to work out the probability it's odd, we need to know how many of the possible outcomes are odd. Okay, so there's 3, 3, 5, 5, and 5. Okay, so that's 1, 2, 3, 4, 5 possible outcomes. So there's 5. Okay, and then we need to know how many total outcomes there are. Okay, and the probability is essentially just, or in this case, the probability that it's odd is the chance that we get an odd number out of the possible number of outcomes, okay, which is going to be 16 because we've got 4 by 4, okay, so 16. So the probability is going to be 5 out of 16, okay. Right, next one. The same game is played using spinners C and D. The numbers on C are shown. Okay, so we need to fill in the numbers on this spinner, basically. So we're told that whenever there's 2 numbers that are different, we choose the higher number. Okay, so if we've got 4 as our higher number, then we know that this one must be 4. Okay, because we've chosen the higher number. Now, we can't work out this one yet. Okay, so let's look at this to see if we can work out this. So we know that when the numbers are the same, we get a 0. So if this number's 4, this must also be 4. Okay, now let's try and work out this one. So we know that when the numbers are the same, then the answer is 0. So this must be a 7. And we know that when the numbers are different, it's the higher number, so this one must be 8. Okay, and now that we've got this, we can fill in the rest of the board. Okay, so 4 and 1, higher number, choose the higher number. Okay, if the numbers are different, we choose the higher number. Numbers are the same, so it's going to be 0, higher number, higher number, higher number, higher number, higher number again, higher number again. Okay, there we go, that's it. So you need to write the numbers on the spinner now. So 4, doesn't matter which way around you write them, it's all the same. So 4, 4, 7, 8, okay. Next one. So 2 people working at the same rate will take 6 hours to paint a room. Assuming they all work at the same rate, how long will it take all 3 people to paint the room? So the way that I like to look at this, I'll say, well, 2 people take 6 hours. And you need to ask yourself, well, what would you expect if 1 person painted the room? Would it be done faster or slower? And well, if there's half as many people, it's going to be done slower, isn't it? But the question is, well, how much slower? Okay, now what you're going to do is you're going to say, well, to go from 2 to 1 people, you've divided the amount of people by 2. Okay, but we can't divide this by 2 because that would make it go quicker. Okay, because we're into 3 hours. So what we've got to do instead is we times by 2. So if you cut the number of people in half, then it will double the amount of time taken. Okay, so we need to times the time taken for 2 people by 2, which gives us 12 hours. Okay, so what you can see is you can see that when we divide the number of people by 2, we have to times the time taken by 2. Okay, so let's try the same exercise but for 3 people. Okay, this time going from 1 person to 3 people. Okay, so if we go from 1 to 3, we have times the number of people by 3. So as you can see, if we divide on this side, we times on this side. So if we times on this side, we should divide on this side by the same number. Okay, so this is divided by 2, this is times by 2, this is times by 3, so we divide by 3 the time. Okay, so that'll give us 12 divided by 3, which gives us 4 hours. Okay, and it makes sense as well, because if you have 3 people doing it, it's going to take less time than 2 people doing it, yeah, or one person doing it. So the next question is, it doesn't require any maths really, it's just sort of a, rationalising why something is the case, okay? So the third person works at a faster rate. Okay, so if you've got 3 people and they're all working at the same rate and it takes them 4 hours, if 1 person works faster, it's going to take less time, isn't it? Okay, so how does this affect the time to paint the room? It's going to take less time to paint the room if the third person works faster, okay? Because they'll get more done quicker, okay? So 3a plus b is equal to 7. And 6x plus 8y is equal to 40. Now, we need to show that 9a plus 3b has a greater value than 3x plus 4y. Okay, now, this might not be immediately obvious what you have to do. So if you just write them out like this, 9a plus 3b, 6x plus 8y, and 3x plus 4y, that's equal to 40. So we look at this and we say, well, to go from 3a plus b to 9a plus 3b, it looks like we've times everything by 3, doesn't it? So let's do that to the answer. Now, going from 6x plus 8y to 3x plus 4y, it looks like we've divided by 2. So let's do that to the answer. It gives us 20, okay? So show that 9a plus 3b has a greater value than 3x plus 4y. Okay, so it's quite clear that 21 is more than 20. Okay, so 21 is greater than 20. Yeah, and then you put some arrows like this if you like, that makes it clear enough. So we've just shown that this is more than this by taking the answer for what we do know and then multiplying it by 3, okay, because we can see that the numbers here, here are 3 times the numbers here, and the numbers here are half of the numbers here, okay? So the same follows for the answers. Okay, so next one. Circle the point that lies on the line x minus 3 is equal to 0. Okay, so this needs us to do a little bit of rearranging first. Okay, so x minus 3 equals 0. So what this means, okay, it means if we have a graph like that, and we've obviously got the y-axis here, y-axis, we've got the x-axis. What it means that if you take the x value and you take away 3 from it on this line, you will always end up with 0. Okay, now let's think about this. So say we've got numbers here. Let's say 3 is there. Okay, if we take our x value and take 3 away from it, we always get 0. That means that we always end up on the y-axis, okay, because this is where x equals 0. So for that to be true, then our line has to be straight down through 3, x equals 3, okay, because if you think we're here and we take 3 away, we're going to end up back at 0. If we're here and we take 3 away, we're going to end up back at 0. Okay, so every single point along this line, if we take 3 away, we're going to end up back at 0, okay, which is what this is saying. It says if you get x, your x value, which is this, and you take away 3, you will always get 0, okay? So that means that our line is x equals 3. So what we need to do now is we need to find which of these coordinates has an x value of 3, okay? Now when you write coordinates, you write it as x first and then y. So we need to find the coordinate where this value is 3. And we can see, well, it's this one, okay? So this is the right answer. It's not this one because x is 0 there, x is minus 3 there, and x is 0 there, okay? So it's none of those. Now, next one. So a is a negative odd number. Circle the words that describe a squared. Okay, now the best way to do this is just to think of a negative odd number. Okay, so let's think of, say, minus 3. Okay. Circle the words that describe a squared. So let's square this number. Okay, so when we square this number, what it means minus 3 times by minus 3. Okay, so we do the numbers first. So 3 times 3 is 9. Okay, and then we look at the signs. So a negative and a negative cancels out. So we end up getting a positive 9. Okay, so a negative odd number squared gives us a, what's this? This is a positive odd number, okay? So it's going to be positive and odd, okay? It's not negative, can't be negative, because when you square a number, you always get a positive number, okay? And then 9 is an odd number, okay? So it must be odd, okay? So the next one, circle the ratio, which is the same as the scale. 1 centimetre represents 1 kilometre. Okay, so what this means, it means that if we have a map like this. Let's say we have a map and we have some islands. So we've got, let's say the UK, I'm going to make them circles. The UK, and then we have, let's say, France here. Okay. Now, on a map, you'll often see that in the little bottom corner, you'll probably have a scale. Okay, now let's say the scale is 1 centimetres long. And then what it will tell you is it will say, well, how many kilometres does that centimetre on the map represent in real life? If you have a map like this, this map is only going to be relatively small. It's going to fit on a table. You know, it's going to be relatively small. So we need a way to work out, say, what the distance is between the UK and France without actually having to go from the UK to France to measure it. So what we'll do is we'll put our ruler on here like this, and let's say that's 30 centimetres, and each centimetre represents 1 kilometre. Then we know that in real life that's 30 kilometres. Okay, so that's what this question's talking about right now. It's saying, well, how can we use the scale of a map to work out what the real distance is between some points? Okay, so it's saying here 1 centimetre to 1 kilometre is the scale. Okay, so 1 kilometre. So what it's asking us to do is asking us to show, well, how many centimetres in real life are there for every 1 centimetre on the map. Okay. Now, the way that we do that is we need to convert 1 kilometre into centimetres. So 1 kilometre into centimetres. Okay. Now, if we let's draw this. So let's say, okay, so we've got a kilometre, 1 kilometre, and then we have down from there we're going to have metres, and we're going to have centimetres. Okay. So to go from kilometres to metres, the prefix kilo, okay, so kilometre, like this. Kilo means 1,000. So that means that 1 kilometre is 1,000 metres. Okay, and we know that in a metre, 1 metre is equal to 100 centimetres. Okay, so to go from kilometres to metres, we've times by 1,000. And if we want to go from metres to centimetres, we have to times by 100. Okay, so that's what we've got here. So if we've got 1,000 metres and we want to convert that into centimetres, we have to times that 1,000 metres by 100. Okay, because there's 100 centimetres for every 1 metre that we have. So if we have 1,000 metres, then we have 100,000 centimetres. Okay, sorry, 1,000 metres then is 100,000 centimetres. Okay, so that means that 1 kilometre is equal to 100,000 centimetres. So that means that 1 centimetre on the map is 100,000 centimetres in real life. So that means it's this answer. Okay? Right, next question. Circle the percentage that is closest in value to 1/3. Okay, so this is one of those things that you kind of just have to know. So a third, if we write a third as a decimal, okay, you should know that it's 0.3333333 dot dot dot. Okay, it keeps going on like that. Okay, it's called a recurring decimal. So it basically just means it goes on forever like that. So if we want to convert from a decimal into a percentage, we have to multiply by 100. Okay. So 0.33333. Okay, so to go from a decimal to a percentage, we times by 100. And we put a percentage sign in front as well, that's important. So if we times by 100, we move the decimal point 2 places to the right. So this becomes 33.33333 dot 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 percent. Okay, so that's our answer. That's a third as a percentage. So circle the percentage that is closest in value to 1/3. Okay, well, it's going to be this one, isn't it? Yeah. If this number here was over 5 or equal to 5 or above, then this would be the answer. But yeah, because it's 33.33, this rounds down to 33.3. Okay, so that's the answer. Work out square root of 121 minus 13 minus 5 times 2. Okay, now this is a case for BIDMAS. Okay, which means brackets first, indices second, division, multiplication, addition, and subtraction. Okay, so let's look at the brackets first. So we have 13 minus 5 times 2. Now, we need to apply BIDMAS within the brackets, okay, because we've got a multiplication and a takeaway. Okay, so we need to do the multiplication first. Okay, so that's the first order. So let's write everything out. So square root of 121 minus, so we're doing the brackets first, 13 minus, and then we need to do the multiplication, so 5 times 2, which is 10. Okay, now we don't do the squared first because that's on the outside of the brackets, so we do that afterwards. Okay, so we only look at the inside of the brackets at the moment. Now we've still got brackets, so we've done the multiplication inside the brackets, but we've still got this sum in here, so we need to finish that off. So square root of 121 minus 13 minus 10 is 3 squared. Okay, now we can just get rid of the brackets now because they're not doing anything. Okay, so we've done the B. I for indices. So when we do indices, square roots count as indices, and so do squareds. Okay, so we can do those both at the same time. So we'll do this one first. Square root of 121 is 11 minus 3 squared, which is 9. Okay, and then simply just do this, which is 2. Okay, so the answer is 2. So BIDMAS is important. So we do inside the brackets first, but then we say, inside the brackets, we need to do a multiplication first. Okay, so that gives us 10. And then we do the sum in the brackets, 13 minus 10 gives us 3. Then we do the square root, and then we do the squared, 11, 9 gives us 2. Okay. Next one, reflect the triangle in the line x equals 2. So, reflection is simply what you would get if you imagine you put a mirror here, x equals 2, okay? So that's the line x equals 2. Okay, so it means there's a line that goes straight down through x equals 2. That's what x equals 2 means. Now, if you imagine that you had a mirror, and this bit is the shiny side here, so you hold it along the paper like this, what would you see in this side of the mirror? What would you see? Well, you'd see this point would be reflected there, this point would be reflected there, and this point would be reflected there. Okay? So one way you can do this, you can say, well, start at the line, count how many points to the left the first point is, so it's 1 point, and then do the same but the opposite direction. So that's 1 there. So and then you go the next one, so you go 1, 2, 3 points away. So let's go in the opposite direction. 1, 2, 3 points away. This one, so that is 1 point away. So you go the opposite direction, that's 1 point away that way, and then simply just join up the dots. Okay. And then that is our. Make sure you use a ruler for this, by the way. I'm not giving you setting a good example here. But that's the reflection in x equals 2. Okay, simple as that. Now, this next one, I will explain how to do it, but I probably won't be able to show you on my computer. So, what you would do is you would take some tracing paper. Okay, and what you would do is you would draw over the top of this shape like this. You put your tracing paper on there like that. And then what you would do is you would look at these instructions. And this is going to tell us to rotate the kite 90 degrees anti-clockwise. Okay, so anti-clockwise is going in that direction. Okay, about 0, 0. Okay, so that means that you're going to put the tracing paper here, so you've drawn over the top of the tracing paper, and you're going to hold your pencil down on this point, and you're going to use your pencil as an anchor to hold the paper down whilst you rotate this shape, your tracing paper, this way by 90 degrees. Okay, so one thing you can do as well is you can draw a line like that on the tracing paper. So when you move your tracing paper round, you're going to move it 90 degrees until your line is facing this way, and your shape's going to look something like this, okay? But your tracing paper will show you where it's going to end up, and then basically remove your tracing paper and then plot the points where the tracing paper is. Okay, it's hard to explain on here, but that's an instruction on how to do it. Okay, so in general, it will tell you, well, it will give you the amount by which you need to rotate. Okay, so you need to understand your angles. So if we have this here, 90 degrees, 180 degrees all the way around, this would be 270, and then all the way around, which wouldn't make sense because it's just the same thing again, is 360. Okay, and then anti-clockwise, you need to know that this is clockwise and then this is anti-clockwise. Okay, and then whenever it says about a point, that is where you put your pencil as an anchor to rotate the sketch that you've just made on the tracing paper about. Okay, so next one. Anna plays a computer game. Each game is a win or a loss. She wins 3/4 of her first games. She then wins her next 12 games. For all 36 games, work out the wins to losses. Okay, so with questions like this, I like to go down in order. Okay, so I like to work out each bit at a time. So I'm just going to zoom in a bit. So let's have a look. Okay, so first bit here, she wins 3/4 of her first 24 games. Okay, so to work out how many games that is that she's won, I need to do 3/4 of 24. Okay, now to do that, I'm going to work out 1/4 of 24. And when you do 1/4 of something, you divide it by 4. So you divide this by 4, and you get 6. And then to do 3/4, you simply times that by 3, which gives us 18. Okay? So the answer is 18 wins. Okay? And then it tells us she wins the next 12 games. That's pretty straightforward. 12 wins. Okay? So to work out the total number of wins, I'm just going to add these together. So 12 plus 18 gives us 30 wins. Okay. Now, we know that she had 36 games, and it's telling us to work out the wins to the losses. Okay, so I'm going to write the number of wins here, 30, and then I need to write the number of losses here. Now, if she's had 30 wins, but she's had 36 games, then she must have had 6 losses. Okay, because that gives us a total of 36 games now. Okay, so now we need to write it in its simplest form. Okay, so this is the ratio, 30 wins to 6 losses. Okay. Now, the way that we do that is we find the highest common factor between these two. Okay. Now, you might be able to see that it's 6. Okay, but if you can't, then it's useful to make a little list. So we've got 6 there. Factors of 6 are 1, 2, 3, 6. And let's write the factors of 30. So you've got 1, 2, 3, 5, 6, 10. Going to have 15 and 30. Okay, so we find the highest common factor, which is going to be 6, and then we divide by the highest common factor. Okay, so 30 divided by 6 gives us 5. 6 divided by 6 gives us 1. So the ratio of wins to losses is 5 to 1. Okay, and that's in its simplest form. Okay. Now, next one. A solid shape is made from centimetre cubes. So I've covered this in a separate video because it's difficult to explain. I've used a bit of software that allows you to draw the cube, and then I'll add on the cubes to show you how it's done. But go and check that one out if you want to see how it's done. Now divide 405 in the ratio of 4 to 11. Okay, so what this means, it means that if we have 405 things, sweets let's say, and we have 2 people, so we've got Sarah, John. That means that for every 4 sweets that Sarah gets, John gets 11. Okay, so if Sarah has 4, John has 11. If Sarah has 8, John has 22. If Sarah has, let's say, 12, John has 33. Okay, so on and so forth. So we keep doing this until we end up with this total here being 405. We will have the answer, but that's going to take a while. Okay, so there's a quicker way to do this. So what we do is we add up the 2 numbers on the ratio. 4 add 11 gives us 15. And we say, well, the number that Sarah gets to John, the number that Sarah gets is 4/15, and the number that John gets is 11/15. Okay, and then to work out the number that Sarah gets, we're going to do 4/15 times by 405. Okay, now when we do fractions times by like this, I like to put a 1 over the whole number. So we do the times tops together, times the bottoms together. So 4 times 405. Okay, now quick way to do this is if you do 405, I mean you could write 405 4 times, but I like to double it. So I'd get 810, and then double that again. It's going to give you 1620. Okay, so 1620 on the top, divided by 15. Okay, and then John is going to be 11/15 times by 405 over 1. Now this time what I'm going to do is I'm going to do 10 times 405, which is equal to 4050. And I'm simply going to add 405 onto that to give me 11 times. So 5, 5, 4, 4. Okay, so it's going to be 4, 4, 5, 5 over 15. Now I'm going to divide these 2 numbers. So I'm going to do 15 bus stop method, 16, 20. So 15 into 16. So, well, sorry, 15 into 1 goes 0. 15 into 16 goes 1 with 1 left over. 15 into 12 goes 0. So 15 into 120 goes 8 times. So the answer is 8. So this is going to be 108. Okay, and then 4455 divided by 15. So let's try that, shall we? Make some more space somewhere. So 15, 4, 4, 5, 5, 15 into 4, 0, 15 into 44, so we've got 15, 30, which gives us 2, and then we're going to have 14 left over. Okay, and then 15 into 145, that's going to be 9 times with, what's that, 10 left over, so 105. Okay, so that's going to be how many times? So 15, 30, 45, 60, 75, 90, 105. That's going to be 7 times. Okay, so the answer is 297 for that one. 297. Okay, so now the ratio is, so we're going to have 108 and 297. Okay, so what that means is it means that Sarah gets 108 sweets and John gets 97, sorry. Okay. Now, next one. The height of Zach is 1.86 meters. Okay, the height of Fred is 1.6 meters. Write the height of Zach as a fraction of the height of Fred. Okay, now when you read this, it tells you what to write. Okay, so when you see as a fraction of this bit here, just read this as divide. Okay, so height of Zach divided by height of Fred. That's how you should read it. Okay, that's all it means. When it says as a fraction of, it means divide. Okay, so the thing that's before the divide over the thing that's after the divide. Okay, so height of Zach, which is 1.86, divided by height of Fred, which is 1.6. Okay, and then of course, because it's a fraction, we write it like this. 1.6. Okay, now it's not normal to have decimals on fractions, decimals within fractions. So what we're going to do is we're going to make it into a, well, not a decimal. Okay, so what I'm going to say is I say, well, okay, to make this not a decimal anymore, I have to times it by 100. Okay, because I need to move this decimal point, not there, but there. So times by 100 on the top and bottom. 186. So that's going to go 1, 2 as well, so over 160. And then what I'm going to do is I'm going to say, well, I know these are both even numbers, so I'm going to divide top and bottom by 2. So 180 divided by 2 is 90. 6 divided by 2 is 3, so that gives us 93. 160 divided by 2 is simply 80. And we can't cancel that down anymore. Okay, so the answer is 93 out of 80. Okay, next question. A and B are points on the straight line A, B, C, D. Okay, now, what this is asking us, if I can zoom in slightly. So, yeah, it gives us the points on there, doesn't it? So, it's telling us that A to B, which is this distance here, is the same as the distance B to C, which is the same as the distance of C to D. Okay. Now what we can do is we can draw lines across like this. And if we know, let's say this distance is x, we know that they're all equal. A to B is equal to B to C is equal to C to D. These are all the same length. Okay, so we need to realise that Pythagoras' theorem, a squared plus b squared is equal to c squared. Now, if these lengths are all the same, the long lengths, then we must know that these lengths are the same as well. Okay, because if they weren't, these would not be the same. Okay, and with another way that you can tell as well is with straight lines, they have a constant gradient, which means that for every amount that you go across this way, they go up by the same amount. So if you go across 6 this way, it goes up by 3 here. It's going to be the same here. If you go across by 6 this way, it's going to go up by 3. Go across by 6, up by 3. So this distance is 3. This distance is 6. So this distance must be 6, and this distance must be 3. So to get the point C, we add on 6 to the x-coordinate, which is going to be 12. Then we add on 3 to the y-coordinate, which is going to be 8. And then same again. So we know this is 3. Sorry, this is 6. And this is 3. So we add on 6 to 12, which gives us 18. 3 to 8, which gives us 11. So therefore, the coordinates of D is 18, 11. Okay. Next one. A coin is thrown 50 times. It lands on heads 31 times. Okay, so write down the relative frequency it lands on heads. So the relative frequency is essentially, it's just a fraction of how many times a certain thing occurs out of the total number of tries. Okay, so in this case, the total number of tries is 50, and the total number of times that it lands on heads is 31. So the relative frequency is 31 out of 50. Okay, so the relative frequency it lands on heads is simply the number of times that it lands on heads out of the number of times that it was thrown. Okay, so simple as that. Now, Raj says the coin is biased towards heads. Use the data to give a reason why you might be correct. Okay, now the reason that you might be correct is because if you were to throw a coin, okay, you've got a 50-50 chance of it being heads or tails. So that means that you've got a 0.5% chance that it'll land on heads, okay, and a 0.5% chance that it'll land on tails. So you would expect for a 0.5% chance of landing on heads, if you throw it 50 times, you would expect it to give you 25 heads, okay, that's what you'd expect. So that's assuming the coin is fair. Now what we've observed is that there's 31 times that it's come on heads. So that would suggest that the coin is landing on heads more times than it should. In other words, the coin appears to be biased towards heads. Okay? So you would say something like, you would expect a fair coin to land on heads 25 times when thrown 50 times. Whereas this coin has landed on heads 31 times, which is more than what you would expect from a fair coin. Okay, now that's the sort of wording that you would need to use. Okay, next question. 5 times x plus 3 is less than 60. Okay, now the way that you do this is you first expand the brackets. So we do 5 times x, which is 5x, and then we do 5 times positive 3, which is plus 15. And then we keep this the same. It's less than 60. Okay. Now, essentially what this question is asking us is it's saying, well, for what values of x does this hold true? And the way that we can show that is by rearranging it so that we can get x on its own. Okay. Now, the way that we do that is very similar. So if it was something like 5x plus 15 equals 60, we'd rearrange it in the same way. Okay, the only difference is that we've got this less than sign here. Okay, so what we're going to do is we're going to say, well, I want to remove this plus 15 because I want to try and get x on its own. So what I'm going to do is I'm going to take 15 off both sides. Okay, because when you deal with equations, equations are like balancing scales or a seesaw. Okay, if you take one thing off one side, you have to take it off the other as well, otherwise the scales go out of balance. Okay, so you must remember with equations, when you're trying to solve them, if you take something off one side, you have to take it off the other side as well. Okay, so plus 15 minus 15 is less than 60 minus 15. Okay, because we're going to do the same to both sides. These 15s cancel out to 0. Okay, because 15 take 15 is 0. So that leaves us with 5x is less than 60 minus 15, which is 45. So 5 times x is less than 45. So 1 times x must be less than 45 divided by 5. Okay, because to get rid of this 5, we have to divide by 5. So we have to divide by 5 on this side as well. So 45 divided by 5 is simply 9. So the answer is x is less than 9. Okay, so for this statement to hold true, so for 5 times x plus 3 to be less than 60, x has to be less than 9. Okay, so that's what that says. Next question. Okay, the range of a set of numbers is 15 quarters. Or sorry, 15 and a quarter. The smallest number is minus 2 and 7/8. Work out the largest number. Okay, now the range, what that actually means, the range, is equal to the largest number, take away the smallest number. Okay, that's what the range means. So if we know that the range is 15 and a quarter, okay, then to work out the largest number, we just need to add 15 quarters onto the smallest number. Okay, and that'll give us our largest, sorry, that'll give us our largest number. Okay, so if you've got two numbers, so you've got, let's say, minus 2 and 7/8, our largest number is here. I'm going to call it L. This distance here is 15 and a quarter. So to work out this, we just need to add 15 and a quarter onto minus 2 and 7/8. Okay, that's what we're doing. So I'm going to convert these into a different fraction, just to make it easy to deal with. So 15 and 1/4, I'm going to turn it into an improper fraction. 15 times 4 is going to be 60. And we've got 1/4, so it's going to be 61 quarters. Okay. Now, minus 2 and 7/8. I'm going to say, well, minus 2 times 8 is minus 16, plus the 7/8 that I've got is going to be 22, 16 plus 7, 4, 3, yeah, 23, minus 23/8. Okay, now I'm going to convert these quarters into eighths. So to do that, I need to multiply the top number by 2. So I get 122 over 8. So now I'm going to add the smallest number, or sorry, I'm going to add this onto the smallest number. So that gives me minus 23 over 8 plus 122 over 8. So 122 minus 23 is going to be 99 over 8. Okay, and that's our answer, 99 over 8. And that is our largest number. Okay, so minus 2, yep, clear that. So the next one, y is inversely proportional to x. Complete the table. Okay, so if y is inversely proportional to x, that means that y is proportional to 1 over x. Okay, now what this means is it means that y can be calculated as k, some number over the x value. Okay, now because we've been given two values here, we can work out what this k is. Okay, we can say, well, we know that y is 4. Okay, we don't know what k is, but we know that the x is 6. So we know that 4 is equal to k divided by 6. So to rearrange this, we need to get rid of the 6, okay? And the 6 at the moment is a divide by 6. So to get rid of that, we need to times by 6 on both sides. So times by 6, times by 6. So if we times 4 by 6, we get 24. And if we do k over 6 times by 6, we just get k. So k is equal to 24. So what this gives us, it gives us y is equal to 24 over x, okay, because we've just replaced k with the value that we found for k, which is 24. So now this actually here tells us what the rest of the numbers are. So y, which is this number, is equal to 24 divided by x. So 24 divided by 12 is 2, okay, because we've done 24 divided by x, which is 12. So 24 divided by 12 is 2. Next one, so we need that y, so 8 is equal to 24 divided by x. So what number do we need to divide 24 by to get 8? So some number times by 8 is 24. Okay, so the way we do that is we say, well, x is equal to 24 divided by 8. Okay, so we bring the 8, so the x across here, and the 8 on the bottom. 24 divided by 8. What does that give us? It gives us 3. Okay,